How I install the NFS server? First, I ping the network, check the networking part if it's good or not. So 192.168.1.31 is my master IP address. So first I checked and then I created one directory inside home NFS share data and then dnf y install NFS util. There is a one command that I need to one package that I installed and go inside etc id med file and domain equal to example.com. I will cover in my lab, don't worry. And when I do after that, I open one file etc export and then write it here. Export RV systemctl enable RPC bind. After the reboot of this NFS server, this should be working fine. So I enable this service, flush the IP table rule, export a cd NFS share ls and touch one file system. Just create one file so that I can check this file should be visible when I mount my pod. Enable RPC bind. I guess this is a copy paste mistake here. RPC, yes, this is the copy paste mistake here. On the worker node, this is what I did on the NFS server in the fourth VM. So what I did in the worker node or master node, if you are not using any constraint, so you are also creating your pods or deployment on your master node, then you have to install this NFS util on master and worker nodes. If you're using master not for workloads, so you need to execute this command only on worker nodes. So NFS util, this is the helper. I already covered that we need to install one package so that it can mount this directory. So this package should be available. Okay, so let's move forward. So these are three my YAML files and I just copied in a single YAML file here. So you can use hyphen 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 to segregate. So one file I created here and then use kubectl apply -f nfs. This file I just created with the help of single YAML file. I created all these three: persistent volume, persistent volume claim, and pod. I had already covered in my previous video how you can add. For just for information that the first YAML file is here, and after that three hyphen, then second YAML file, and then three hyphen, and then last. That's it. Here kubectl, if I execute this command kubectl get pod, I can see that my pod is running. And further, if I execute this command kubectl get pv, pv is a short form persistent volume, I can see that reclaim policy is recycle and claim is task pv claim. So it means that this pv is claimed by this pvc and it is in bound state. Bound state means everything is bound. So the name of this pv is nfs pv. The capacity is 3 gig. Access mode is read write. X means many. Reclaim policy, I have already mentioned that there are three types of reclaim, delete and recycle, and which status is bound. Again, there are four types. One is available. The PV is free and not yet claimed or bound. Bound means the PV has been claimed or bound. So it's showing status is bound. So it means that this is already claimed by this PVC. Release, the bound PVC has been deleted. So if PVC is deleted, then you will see this release state and PV is free from its previous bounded state. And failed, the PV has failed its automatic reclamation. Let's move forward. The claim, as I said that this is already claimed and storage class is NFS. That's it. And if I execute kubectl describe PV and then PV name, I should see here volume mode is file system, node affinity is none. All these information are same, but there are a couple of more option you will see when you use describe subcommand. And the source is this NFS. Server IP address is this, path is this. Okay, let's go read only false and event. You will observe some event if it's not bound or if you observe some error for the troubleshooting purpose. It is good to use these events. For me, I was very lucky, so I didn't observe any alarm here. So kubectl get PVC. So PVC is bound and the volume name is NFS PV. As I mentioned previously that my PV name is NFS PV. So this is what it is saying, volume NFS PV, and access mode is read write many, and storage class is NFS. It should be storage class name should be same on PV and PVC, then only it can bound, right? If I execute kubectl describe PVC, so again I can see more option. Namespace is default. We can use the namespace because PVC is a namespace object. Label, we can also select the labels. Annotation we can select here and used by my pod. So there are some couple of more options you can explore with the help of describe subcommand. And event again, it's an important one. Describe pod. So the third one is pod, my pod. From the container section, you will observe mount, and here you will see that where www.html from my pod. So this is the directory. You will observe the volume directory, and inside this volume you will observe all these information here. Claim name is task pv claim. So this is my PVC name. So kubectl execute if I log in inside my pod bin bash and go to this directory, and after that if I do ls I can see this file.txt because this file I created when I configured the NFS server. Echo file updated inside the container file 2, and in the NFS server if I go to this directory NFS share, I see file 2 that I created inside the container. I can also update this file from the NFS server. There is no limitation. As you can see here that file updated from the NFS and append sign to file 2. And if I use cat, I can see 2 lines here. And if I cat this file from my container, this is my pod container. As you can see here that this is my pod. So cat file 2, I can see the updated file here. Next, we can delete this pod and the file should be remain in the NFS server. This is what I will do in my lab section. It is not good to move the PPT. So we are technical guy and we are believe on some command execution and output. So I will show you in the lab section. So static is complete. Let's talk about dynamic. Generally in the office there are two different teams. One is managing the infra part, means physical servers, VM, Kubernetes, cluster, backup and so on. And the second is managing the application part, which means all the application running inside the Kubernetes cluster such as deployment, service monitoring and so on. Why I'm telling you this? Because second team, that is our deployment team, complaining that every time when we need volume they have to create two objects extra, that is PV and PVC, and then bind it to the pod. How we can minimize it? So Kubernetes come up with one solution that is called dynamic volume. In this, the first team that is managing the Kubernetes cluster will create a storage object in advance, storage class object in advance. Now deployment team need to create only PVC and mention that storage class name in the PVC configuration file, means YAML file. In the backend, PV will be created automatically when we create a PVC. So how it create PV? So PV will create it will take the value from the PVC and the storage. On the basis of that, Kubernetes create automatically one PV. So this is what they for now they need to create only one PVC object. So they don't bother about PV. So let's explore this. It's a good one. So what is dynamic volume? So here we have so here we have one storage and three different storage servers. So we have three different storage server: NFS for simple file mounting, hard disk for backup purposes, SSD for for database servers, and for critical data we use SSD because SSD having a good speeds and HDD is having low speed, so we can use ISO image or backup, we can put it here, and some file system sharing we can use with the help of NFS servers, right? So in this my Kubernetes cluster, NFS Kubernetes administrator already created the storage class for us, right? One is for NFS, one is HHD, and one is for SSD, which means that please bear in mind that storage object is a shareable binary. So one storage class can be shared between multiple PV. Whenever a developer use a volume in pod, he need to create only a single object that is called PVC. Kubernetes binary will create PV automatically, that I have already covered. When we create the deployment, a new pod will be created, and when we create the PVC, a new PV will be created automatically, right? So this pod will access this PVC, and this PVC will access this PV, and this PV will go to storage NFS. Let's suppose if we have another pod, so we have to create another PVC, and this PVC, when we create a new PV will be created, and again it can contact to storage NFS. As I said earlier, this storage object is a shareable object, so we can share this storage NFS with multiple PV, but PV is dedicated to one PVC. Same as it is for third, we can use PVC and then it will go for another storage. I hope it is clear for you why we are using storage and why we are using PV, right? So static and dynamic. Let's talk about theory part of dynamic volume. So we understand that what is dynamic volume. So as per the official documentation of Kubernetes.io, dynamic storage provisioning is the process of automatically allocating storage to container in the Kubernetes cluster. It's being done automatically by the Kubernetes control plane when it detects that a container needs storage. The container plane will select a storage class based on the container's configuration, then automatically create a new persistent volume PV using that storage class. And the last one is after that, as in static provision, the PV is attached to the container and the container can use the storage via PVC. These are the official lines that you may need to learn for the interview purposes, but yes, with the help of previous 3D animation, we get to know that how it works. So let's go to what is storage in our next topic. Storage class objects were introduced in Kubernetes 1.5. A storage class in Kubernetes defines different storage type, which allows the user to request a specific type of storage for their workloads. With the help of storage class, we can control which type of storage is required for specific workload. As I said previously, sometime we are running database server. For that, we need SSD hard disk. So we have a different storage, and sometime we are using only for the backup purposes. So we are using HHD, or sometime we are using NFS storage for file system sharing or for backup. It's up to your organization what you have decided. This is the storage class YAML file. It is very simple. The first one kind equal to storage class, and the second is name from where we can identify it. In here I mentioned NFS hyphen client. It means that this is my NFS storage class, and after that provisioner. This is very important. Here I use NFS and this name must be same in the deployment env provisional name. I will show you in the lab where we have to define this provisioner. And there are different type of provisioner. If you are not using NFS, then you can use AWS, Azure. So these are the official documentation. You can get it from the Kubernetes.io website here. You can use. So this is the internal provisioner and these are the config examples. That's it for the storage class. So let's move on to the lab section where we will configure all the volumes. For dynamic volume, we need to click here dynamic directory and then go to and click on lab dynamic volume. This is the YAML file which consists of service account. As of now, I have not completed this topic, so I will complete it. And cluster role binding is required to give the privileges. And here I'm going to create the deployment and persistent volume claim. And my storage name is NFS client. In the storage class, I have defined here NFS client here. And in the provisioner name, I have mentioned k8sign.io/nfs. Same name I have defined in my storage class here. Here I have also mentioned that this name must be matched in the deployment environment variable. I will cover in my next topic what is this environment variable. For now, you just copy this YAML file, paste it over here, and then apply the YAML file. It will create service account, cluster role binding, storage class, persistent volume claim, and deployment. From this output, you may get to know that I have not created the PV. So when I create this persistent volume claim, PV will be created automatically by the dynamic provisioning. Let me execute this command kubectl get sc is for storage class. Now as you can see here that in the storage class, the reclaim policy is delete and my persistent volume will get this value from the storage reclaim policy. Persistent volume and persistent volume claim I have already covered. So let me describe here for the storage class. So provisioner is NFS, reclaim policy is delete, and volume binding is immediate, and allow volume expansion is false. So I cannot extend this storage class. So let me use this kubectl get pods. So my pod is running. If I delete this persistent volume, so before deleting this, let me show you in the storage, a new directory will be created here. So now you can see here that a new volume is created with this directory DE2948. You will observe the same here inside this persistent volume claim DE2943. If I delete this PVC, kubectl delete PVC, it will delete the persistent volume. Also delete this directory. Let me delete here. If I execute this command, I will see only the storage class. And if I do ls space ltr here, not observe this directory here. Same thing I have mentioned in my lab here. So how to clear the lab? I have to copy this one, right click here and delete all the things. Now I will not see a single thing here. That's it for the dynamic volume.